Okay, we're given the mass of a species of mouse commonly found in houses is normally distributed. Okay, so X is right around, it's normally distributed with a mean of 20.4 and a standard deviation of 0.2. And I always like to kind of write these out here too. Okay. Notice that it says here to round answers to 4 decimal places. So be sure to calculate probabilities using z-scores to 4 decimal places if calculated by hand. That's why I like using technology rather than the standard normal charts that are in your book, because you normally just go to 2 decimal places. So the first thing that I want to do is write out the probability statement. So I want to find the probability that a randomly chosen mouse, that X, the mass, and again this is talking about the mass, is going to be less than 20.24. Okay. So the first thing that I need to do is calculate the z-score. Z is equal to X minus mu over sigma. And remember that this is your X value. So it's going to be 20.24 minus mu, which is 20.4, divided by sigma, which is 0.2. So let me bring up the calculator. So 20.24, subtract 20.4, enter, and then divide that by 0.2. And that's equal to negative 0.8. Now, if this had not been a single to the 10th place, if you had more than that, you would need to take this out to at least 4 decimal places. Okay. So what we're going to do here is next we're going to draw the curve and see what this looks like. The standard normal curve. Let's see what we're getting here. Okay, all I need to know that this is negative 0.8. I just know it's to the left of 0. And I'm wanting it less than that. So this tells me to draw a line up here. And less than tells me to shade to the left. So I have a couple of ways I can do this. I can do the TI, which is going to be second vars. No, let me take it back. I'll cut that out. Okay, since I'm wanting to find this area here, I'm going to be using TI, and I'm going to be doing the normal CDF because it's there. And remember that this is an infinite line, so we in general would do a negative 999,999, comma, negative 0.8 to get the area that corresponds to the probability. So second bars, normal CDF, negative 999,999, comma, negative 0.8. Point 21186. I'll do that. Okay. So let's do stat disk. Okay. Analysis, probability distribution, normal. Okay. the z value is negative 0.8, and remember that again that you would need to put, if it didn't come out nice like this, you would need to put it in 4 decimal places. Okay. And it gives you the cumulative probabilities here. Notice it gives you to the left of it, and it gives you to the right of it. So we want the left of it. So StatDisk is telling me if I can pull that up here. That the probability that X, I'm sorry, and I actually left out one statement here. I should have put this in here. One thing I forgot. Once you calculate your z-score, the next thing that you're supposed to do is the probability that X is less than 20.24 is going to be approximately the same probability that Z is less than the negative 0.8. Okay, so I should have wrote that down before I do this. Okay, so once I do that, probability that Z is less than negative 0.8, according to StatDisk, is, again, here to the left, is 0.21186. Exactly the same thing I got on the TI. And I know the TI is limited to just PCs, and I know probably several have Macs. So let's get in here. I'm going to do 4 decimal places. 0.2119. 4 decimal places. Okay, let's do the next part. Part A here. Let's do part B. What's the probability that a randomly chosen mouse has a mass more than? Probability that X is greater than 20.59. So Z is equal to X minus mu over sigma. This is my X value. So it would be 20.9. Subtract off my mu up here, which was 20.4. And divide that by 0.2. Let's get the calculator back up. .95. So the next thing that I need to do, okay, so the probability that X is greater than that is approximately the same thing as the probability that Z, and again you keep your same symbol here, is greater than this Z value that you just calculated, 0.95. Then I like to draw the curve, a standard normal curve. And all I really care about is this is positive, so I just know it needs to go somewhere to the right. 0.95. 0. And since it's greater than, draw my line up. And shade to the right. Okay, so let's see if I can do this all on one sheet. So on the TI, it's going to be normal, CDF. Now, notice that my left endpoint, CDF. Okay. I wrote CDD, CDF. should be normal. And now it's going to be 0.95, comma, 999,999. It's positive this time because we're going to the right. Second large CDF. So we're going to do 0.95, comma, 999,999. .171. I'll do the round into 4 places. 0.7111. Okay. Now let's go to stat disk. Here. And we're going to go to the Z value. What were we given the Z value was? It was 0.95. 0.95. And just evaluate. And notice that the area to the right, which is what we want. Let's write down the stat disk. So I'm looking here. It's 0.1711. So we're getting the same value. So let's go back here. 0.1711. Now lastly, it's asking, I'll get a sheet of paper here. Okay. What proportion of mass? So what's the probability that the mice have a mass between? So when you do between, you have to put your left endpoint first, which is 20.6 or 20.26. I'm sorry, is less than x. Less than or equal to. It really doesn't matter again because it's continuous probability distribution. Okay. So I have to find a z-score for each one of these. So the first one, z, x minus mu over sigma. I'll be using this x value, which is 20.26. Subtract off. Recall that mu is 20.4. And divide that by 0.2. Get my calculator back up. The first one is negative 0.7. Do the second one. Z is equal to x minus mu over sigma. And now we're going to be using this x value, which is 20.57. Subtract off mu, which is 20.4. By 0.2. Okay, so the next thing I'm supposed to do is where I change these to z-scores is I change the probability statement. So the probability that 20.26 is less than x is less than 20.56 is going to be approximately the same thing as the probability that negative 0.7 is less than z is less than 0.85. And I always like to draw the curve to see what it looks like. So draw the standard normal curve. Put your 0 in there. Okay. The left hand is negative 0.7, so it's just somewhere over here. Really don't care. It's not the scale. And then this one here is positive 0.85. Again, not the scale. So this is the area that I want. So on the TI, it's going to be normal CDF. Instead of doing your negative 99999, the 6 nines, or the positive, we have 2 endpoints here that we're going to be doing. So we're going to put those in there. So minus 0.7, comma, and 0.85. So let's do second large negative 0.7, 0.85. Did I put a comma in there? Yeah, I did. Got the C. It's going to be equal to 0.5604. Right, 4 places. Okay. So let's see what we do on StatDisk Online. I think I'll have to do both of them here. So I'm going to do negative. Let's see what I get here. Negative 0.7. Baby. So notice that it gives me to the left and it gives me to the right. So I'm going to have to do, if I'm using StatDisk here, I'm going to have to do some subtraction. So let me slide this over just a little bit. Okay. So to the left of the, so I know from here to here, let me get a different color. So I'll color that with blue. Okay, so I know that this is going to be 0.24196. Alright. I'll draw a line here. Okay. So now let me go ahead and put in the 0.85. Evaluate. And I get the area. I'm going to look at the right. Okay. So I know here in the right, put a little arrow up there. I'm getting 0.19766. So in order to get the center here, I'll take 1 minus both of these. So let's pull up this, clear that out. 1 minus 0.24196 minus the other part, 0.19766. Okay, little StatDisk. You took 1 minus the 0.24196, subtract off the 0.19766, and you get 0.56038. Okay, to 4 decimal places, it's going to be the same thing, which is great. So we're going to put in here 0.5604. Alright, let me know if you have any questions. Thanks.